Now we're going to talk about special products. Okay, the special product we're going to discuss this question is the difference of two squares. There are certain products that lead to the difference of two squares. Let me give an example. Give an example. Let's say we have like A minus B, okay, times A plus B. Okay, so when we times this, you know, this will be like A times A, and then A times B, and then B times A, and then B times B. Okay, actually negative B times A, negative B times B. Now if we do A times A, we get A squared. A times positive B makes positive AB, and then negative B times positive A, that makes negative BA, but I prefer to write negative AB because BA and AB is just the same thing. Okay, and then negative B times positive B makes negative B squared. Now, you notice that you know, when we times we do products with times binomials, we expand and then we identify common terms to simplify the answer. So now if you look at this, you notice that we have AB here and then AB there. Now because it's AB minus AB, okay, these two can just crossed out. Now we have left with what? A squared minus B squared. Now notice that this product, okay, A minus B times A plus B, which is the same as A plus B times A minus B, leads, okay, to a difference of two squares, A squared minus B squared. Difference because the sign is negative here, okay, and then this is a square, A square because it's raised to the power of 2, B is also square because it is raised to the power of 2. Now if you look at these questions, okay, we have like differences of squares. As you see, we will undo them now. Now let's answer the questions. Before I do, let me write the formula here, the general form. It says like when you have like A minus B, A plus B, this is A squared minus B squared, which is the same thing as A plus B and then A minus B. So still A squared minus B squared, difference of two squares. Now let's start answer the question. Okay, for question 1, we do have like x plus 7 and then x minus 7. So x plus 7 and then x minus 7. Now you notice that our A here is x and then the B is 7. So that's A plus B and then that's A minus B. And then our answer will be A squared minus B squared, okay? So it's like we said, so it's gonna be A squared A, which is x squared minus B squared. Then this will be what? X raised to the power of 2, just x squared. When I simplify, and negative there, and 7 to the power of 2 is 49. That's the answer. Okay. Question 2, we have like x minus 3 and then x plus 3, and then A is x and then B is 3. So it's gonna be like difference of the squares. Okay, so x raised to the power of 2 and then 3 also to the power of 2, and then this makes what? X squared minus 9. Now let's take this other question 3. We have like 2x minus 1 and then 2x plus 1, and this will be what? 2x and then minus 1 there. So our A is 2x, not just x or just 2, but 2x is A, B is 1, okay? And then, so this will be A squared, so 2x to the power of 2 minus B squared, so 1 to the power of 2. And then this will be 4x. Okay, remember, the power of 2 here is applied for both 2 and x, not just 2, but both 2 and x. In the previous grades, we learned this formula when we have like A times B raised to the power of m okay, the power m is applied for both a, okay, and b. Then also here the power of 2 will be on the 2 and also on the x. So this will be 4x squared minus 1 squared, which is just 1. Okay, question 4, we have like 9x plus 4 and then 9x minus 4. So this will be 9x minus 4 there, and then this will be like to the power of 2, and that also to the power of 2, and then this will be 81, because 9 squared is 81, x squared is x squared, 4 squared is 16. 4 squared is 16. Okay. Let's move question 5. Question 5 here. We have like 3x minus 2y, and then 3x plus 2y. So in this case, we write 3x and then we write also 2y there minus. Now this is like a, and that be a plus b. So this will be to the power of 2, and that also to the power of 2. Okay, and then this will be like equal to 9x squared minus 4y squared. Okay, and then question 6. Question 6, we have like 4a cubed b plus 3, and then 4a cubed b minus 3. Then same thing, all this is a and b is 3, and then all this is a and that's also b. Then this will be like 4a cubed b minus 3. Now this will be like to the power of 2 a squared, like this a squared minus b squared. Then applying that property, the power of 2 is for 4, that makes it 4 squared is 16. The power of 2 will be on a to the power of 3. Remember, the rule says that, okay, let me first write it like, it's going to be a to the power of 3, a to the power of 3 to the power of 2, to the power of 2, and then b squared minus 9. Now, the rule, the property says a raised to the power of m or to the power of n. This will be equal to a to the power of mn, and then this will be 16 a to the power of 6 b squared minus 9. Okay, and then question 7. Question 7, we have 6 minus 3x to the power of 4y, and then 6 plus 3x to the power of 4y. Okay, this will be then 6 okay minus 3x to the 4y to the power of, so it's gonna be like 6 to the power of 2, and then that also to the power of 2, and then this will be like 6 squared is 36 minus 3 squared will be 9, x to the power of 4 to the power of 2. So with these cases we make 4 times 2, which is 8. So x to the power of 8, and then y to the power of 2. Okay, and then we have question 8 now. I'll write it here. 3x minus 2 plus y. And then 3x minus 2 minus y. Now over here, you'll see that we have like 3 terms. Now these 3 terms can be shortened to 2 terms. How? I can say this whole thing here is my A, okay? And then it's like A and then plus B. So A plus A minus B here, okay? Sometimes someone may prefer to rewrite this, this way. We can write it like, you can use square brackets and then write 3x minus 2 in the bracket like that, okay, plus y, and then another square bracket there for 3x minus 2 minus y. So we have like two terms. This is the whole thing, the bracket make one term, okay? So like this plus y or this minus y, okay? So over here, we still going to apply the difference of two squares, which will be 3x, okay? 3x minus 2 raised to the power of 2, okay? And then minus y to the power of 2, okay? And then we can stop here, or we can expand this. This will be 3x minus 2 times 3x minus 2, okay, because the question says expand, we can expand this minus y squared. And then over here, we can just apply our technique, because here we don't have, note that this is not a difference of two squares. This product doesn't lead to the difference of two squares, okay? Because we have like 3 minus 2 and then 3 minus 2. If the sign were a difference, like let's say if that side was a plus or that side was a plus, then we could say, we could apply our formula for that leads to the difference of two squares, but it's not the case here. Over here, instead, we're gonna do 3x times 3x, 3x times negative 2, and negative 2 times 3x, and negative 2 times negative 2, and this will be equal to 3x times 3x makes 9x squared, and then 3x times negative 2 makes negative 6x, negative 2 times 3x makes negative 6x, negative 2 times negative 2 makes positive 4, minus y squared. Is there anything to simplify here? Are there lactams? We can notice that these two are lactams, okay? And those lactams don't just cross out because there are things to do there. We can combine them, so it's going to be like 9x squared. Negative 6 minus 6 is not 0. Negative 6 minus 6x not 0. This is negative 12x, okay? And then plus 4 minus y squared, okay? Now we can also do question 9 over here. 1 minus a to the power of 4. We write it here. Question 9. You have like 1 minus a to the power of 4, open brackets, right? 1 minus a squared, 1 plus a squared, okay? 1 minus a squared, and then 1 plus a squared. Now, notice that in this case, we have a difference of two squares here. This product will lead, I mean, this product here, first, this product leads to a difference of two squares. So I will keep the first product as 1 minus a to the power of 4, like that. And then the next product will be 1 squared, okay, minus a squared to the power of 2. Okay, this will be like 1 minus a to the power of 4, and then 1 minus a to the power of 4. There. Now, over here, it was, okay, yes. Over here, note that this product will not lead to a difference of two squares, because it could have led to the difference of two squares if one of the sign alternates, okay, but sign do not alternate. This is negative, that's also negative. If it was positive here or positive there, then we can say we could apply again the difference of two square formula. So in this case, we can just times, we do 1 times 1, and then 1 times a squared times 1, and then a squared times a squared. Then this will make 1 times 1 makes 1, minus 1 times a squared. Negative a to the power 4, negative a to the power 4 times 1, negative a to the power 4, and then negative a to the power 4 times negative a to the power 4. Negative make positive. Now, I need to remind you, this law of exponents that says a to the m times a to the n, okay, equal to what? So when the bases are the same, like in this case, we just write a and then we add the exponents, okay? So in this case, the answer will be a to the power of 8. 4 plus 4 will make 8. And then we can combine like terms because we have like a to the power 4, a to the power 4 there. This is not a to the power of 8. No, this is rather negative 2a to the power of 4. Okay? Because it's not a product and then there's no rule for in this case. So it's going to be plus a to the power of 8. So that's the final answer. Thank you.